The true percentage of people who prefer chocolate chip cookies is between 85 to 90% of the population. But how confident are we in this claim? In order to come up with claims such as this, researchers use confidence intervals to show how good an estimate is. I'll take it from here. So let's say that I was 99% confident that the true population of people who prefer chocolate chip cookies falls between 85 and 90%. If I surveyed a random group of people repeated 100 times, in 99 out of 100 people, 85 to 90% of people would choose chocolate chip cookie as their favorite cookie. Therefore, I can accurately claim that I am 99% confident that 85 to 90% of the population prefers chocolate chip cookies. Let's explain how this relates to the interval portion of our confidence interval. As a general rule, confidence increases as the interval widens, so we could confidently say that the percentage of cookie lovers falls between 50 and 100%, since this is a really large interval which allows a lot of room for error. On the other hand, we are much less confident that the interval of chocolate chip cookie lovers is between 85 and 90, since this is much more specific. Therefore, if we want a really small interval, we also need to decrease the confidence. The equation for a confidence interval is modeled as p hat plus or minus z times standard error. Let's use this equation to solve this problem. A randomly conducted survey found that 85% of 100 subjects chose chocolate chip cookie as their favorite cookie. Create a 95% confidence interval to find the true rate of chocolate chip cookie lovers. We must ensure that this situation meets 4 conditions. Is the data independent? Is it random? Is the sample less than 10% of the population? And do we expect more than 10 successes and 10 failures? Since this situation passes all the conditions, I can now use a 1 proportion z interval. Our first step is to plug our estimated center in for p hat, which in this case would be 85%. Our next step is to find our z value, otherwise known as our critical value. Since for this situation we were asked to create a 95% confidence interval, our critical value would be 1.96. Yes, there is fancy math that we could do to calculate this critical value, but I recommend just memorizing the most commonly used z-scores. Now, we need to find our standard error, which equals the square root of successes times failures divided by the number in our population sample. Now that our confidence interval equation is nicely full of numbers, it is time for my best friend, the calculator. Now we have 2 values, 0.78 and 0.9199. So, what do these numbers mean? We are 95% confident that the true amount of chocolate chip cookie lovers falls between 78% and 91.99%. So we could repeatedly take samples of 100 random people and 95% of the time between 78% and 91.99% of them would make the right decision and choose the chocolate chip cookie.